Today we're going to be talking about rotations. Yes, this is a good one. But first we want to define in our notes what exactly a rotation is. Officially, it is a turn around a fixed point, and that fixed point is called the center of rotation. The figure rotates at a specific angle and direction, right? So you have both pieces. So we're headed over here in a counterclockwise fashion, and that's usually the way we move, unless otherwise stated, counterclockwise. And this is our center of rotation. So A goes to A prime. But now, let's stop and construct an organizer. So you have a single sheet where you have this on one side. And what you're going to want to do is you're going to need to stop the video and get this done. So stop when I say, but first let's just take a quick look. You're going to want to fold the paper down so that this side folds down over the other two. And there's a couple of lines right here. It's really, I would sort of focus on 4. This is how we want to fold along this line and then backwards around this line. There's some extra paper here, and I believe here, that you're going to want to trim off with scissors, and then you're going to want to cut down only on the upper section. Do not cut here, just so that we have this piece cut and this piece cut, and we'll be able to flip it upwards so that we have sort of a nice little graphic organizer. So go ahead, get that folded, cut, and trimmed, and then tune back in. Press pause now. Okay, now that you have your graphic organizer squared away, what we want to do is work the first fold out piece, the 90-degree piece. So you flip up the 90 degrees and you see this information. So we want to figure out what happens to the pieces. So go ahead and plot A, B, C. Right? Press pause and plot A, B, and C on the graph given over here. So now I have plotted my figure. And what we'd like to do is to rotate the figure. So we're going to rotate it 90 degrees clockwise. So when we look at our grid, 90 degrees clockwise, counterclockwise I should say, is 1/4 of a turn, right? If I went from here all the way to here, that would be 180 degrees. From here all the way to here, 3/4 of a turn, that would be 270 degrees. And of course, if you go all the way around, that would be a 360, right back to where you originally started. So let's take it and go ahead and rotate it 90 degrees. Okay. Now, if you just had spun it like that, just for a moment, let's count and see where we're at. Our A is now technically A prime, and A prime would have been 1 to the left and 2 up. So A prime would be -1, 2, where it was originally 2, 1. So let's see, 2, 1 maps to -1, 2. So it looks like my x, y switched. My x was positive, it still is. My y was positive, now it's negative. So it looks like x, y gets mapped to the opposite y, comma, x. And that's going to be our permanent pattern for 90-degree rotations. So let's try to talk this out again. Again, A got mapped to -1, 2. That's right here. So that's our A prime. And B was originally 3, 8. They're going to switch to 8, 3. And the Y value is going to get mapped to the X, opposite sign. And C started at 7, 2. They're going to switch. That's going to be 2, 7. But the 2 is going to change signs. So B is -8, 3. That's right here, our B prime, I should say. And C prime is at -2, 7. That's our C prime. And we connect them. And that's our original rotation. Now, one way to do this in class is to trace this onto what we refer to as patty paper and spin it so that you can see the rotation. You can ask me for patty paper in class. But this rule is going to be the rule every time for 90 degrees, which is why we want to keep this in a nice little foldable format so that we can go back and look at it to help us with other problems. Now we're going to go ahead and develop the pattern for the 180 rotation. So press pause and plot your X, Y, and Z points now. Press pause and plot those. So now what we want to do is actually rotate the figure, and we're going to focus on a 180 degree rotation about the origin. So here's our origin. We want to spin halfway around. So we're going to just go ahead and grab the graph and spin. That's 90, and all the way another 90. Just bear with me here a second. I have a object grabbing problem. Okay, and there we go. Now where was Z to begin with? Z to begin with was at -1, 2. So -1, 2 is where Z started, right? I'm just focusing on C. And technically this is now Z prime. And where is it? It's at 1, -2. 1, -2. So what happens on the 180? The 1 was originally positive, or negative rather. Now it's negative. The Y was originally, right, positive. Now it's negative. So it looks like we took our XY coordinates and we mapped them to the opposite of what they were originally. So XY gets mapped to -X, comma, -Y, or really the opposite of X, opposite of Y. So if I take X, -5, -1 is going to get mapped to +5, +1. Let's check that out. Where is X now? X seems to be over 5 and up 1. Looks to be 5, 1. So the rule works. So let's finish up now. So if -5, 1 went to +5, +1. -7, 6 is going to go to +7, -6. And -1, 2 is going to go to +1, -2. And let's go ahead and plot those points and label it up. Okay. Our last one's going to be a 270 degree counterclockwise motion. So if you go 270 degrees, this is essentially a 3/4 rotation versus this is a half of rotation. So if you start somewhere in quadrant 1 and you go 270 degrees, you should land in quadrant 4. Right? So you should move 3 quadrants around. All right, let's see how this works in application. First, let's plot our 3 original points and label them A, B, and C. Press pause and do that. Or I should say, sorry, P, Q, and R. My apologies. Okay, so now we're ready to rotate. And keep in mind, we're going to go all the way 270 degrees counterclockwise. And let's focus on where Q is going to land. Okay, so I'm going to have to try to grab the graph here. So here's 90 degrees, and then here's 180 degrees, and then here's 270 degrees, and you can try your with your patty paper. And again, I just want to focus on Q. Q was originally at -6, 0, and now it's at +0, 6. So -6, 0 went to, or mapped to, 0, 6. So let's put that right here. And that's going to be Q prime. Now what happened? It looks like the X's and Y's switched spot. And what was once negative is now positive on the X value. The Y stayed the same. So -6, 0 went to 0, +6. If the Y and the X's switch spots, right, I have -8, 5. 5 and 8 switch spots, but the Y value is going to stay the same. The X value goes to the opposite sign, so -5 became positive. On R, they're going to switch spots, so the 1 and 2 switch. The Y stays the same. The X becomes positive. So let's go ahead and plot those and connect them. And again, does this make sense? Well, we did go 270 degrees. That makes about, visually seems to be about right. Right over here, 180 degrees. looks to be in the opposite coordinate, right, across the way, 180 degrees. So we're thinking about what makes sense in these degree rotations has to make sense with what my eyes see. And that's my best, quick, fast eye. All right, let's try this again. Now that we have our graphic organizer, let's go ahead and let's press pause, go back to the beginning of our notes, and let's fill in all this information so that we have this in two places. For 90-degree rotations, XY gets mapped to the opposite of Y, X. They switch spots and Y changes the sign. We'll jump down to the 270, what happens? XY gets mapped to YX and the X changes the sign. So on 90 they flip-flop, Y changes. On 270 they flip-flop, X changes. On 180 they don't flip-flop, but they both change signs. Okay? And so that's in a nutshell what's happening. Now we're going to use our graphic organizer and these rules to apply a bunch of rotations. And we can use the patty paper to trace and check. Now that we have our rules, it's just a matter of applying the rules in a careful fashion. Our first problem in the notes section is a 90 degrees clockwise rotation. So what does 90 degrees ask us to do? It asks us to map XY to the opposite of YX. So first, let's plot our original points, A, B, and C. Press pause, plot the points. So I have my A, B, and C. Now, let's take a look at A. Where does A get mapped to? 2, 7 is going to get mapped to the opposite Y, X. So again, they're going to switch. If they switch, that means that 7 here is here and 2 is here. Now they were both originally positive. The Y should be the opposite sign. I go 7, 2 over here, and that's my A prime. Now let's try it with B. It was originally 6, 5. 5 and 6, switch spots. The Y was once positive, now it's negative. Negative 5, 1, 2, 3, 4, 5. 6 should be 2 from the top because these are 8 by 8 grids. And there's my B prime. And then C prime is going to be 4, 1, maps to 1, 4. The Y changes sign. That's negative 1, 1, 2, 3, 4. And there's my C prime. And I know that if I have a 90-degree rotation, that it should only go into the next quadrant to the left, counterclockwise. And we're all set. For number 2, we have a 180-degree rotation. So what happens here? I have P is at 2, 6. So that's 2 right and 6 up. So there's our P. Now, if I have a 180-degree rotation, that means it's going to go from quadrant 1 to quadrant 3. Our rule for 180 degrees says that 2, 6 is going to get mapped to the opposite of X, opposite of Y. So it's still going to be a 2 and a 6, but they're going to change signs. So P prime is at negative 2, negative 6. So 2 left, 6 down is going to be P prime. So on and so forth with Q, R, and S. So I'm not going to plot the originals. You can do that on your own. But let's just talk about the coordinates. 6, 5 is going to get mapped to the opposite, negative 6, negative 5. 5, 1 is going to get mapped to the opposite for both, negative 5, negative 1. And S prime is going to get mapped to the opposite, negative 1, negative 2. Now you finish plotting and finish this question. Again, I'm not going to plot the points here. I'm just going to talk our way through this. We have a 270-degree counterclockwise on number 3. So I look at my 270-degree rule. That's how I'm going to apply things over here. Right? I'm using my graphic organizer. I'm flipping up the 270 degrees, and I see that X, Y, right? My 3, 4 is going to get mapped to Y opposite of X. And again, what's happening? They're switching spots, and the X is switching signs. So 3, 4 is going to go to J prime. They're switching spots, so 4, 3, and the X is going to get the opposite sign. For L, 8, 1 is going to go to L prime. They're going to switch spots, and the X is going to switch signs. So you go ahead, press pause, and finish this problem. Most importantly, paying attention to making sure that these coordinates are right, and then try to plot carefully. If you need some extra pencils, colored pencils, help yourself. And again, use the patty paper to spin and make sure you check your answers. Moving on to number 4, we have a 180-degree rotation. Notice it doesn't say clockwise or counterclockwise. It's because it doesn't matter. Halfway around is halfway around. But we're sticking with the counterclockwise idea. So 3, -2 is going to get mapped to opposite of x, opposite of y. So if I have 3, -2 originally, I'm going to just change their signs. 3 is going to be negative, and 2 is now going to be positive. 6, 1 is going to stay in the same spots, but their signs are going to flip-flop. They were both positive. Now they're both negative. And z was 5, -7. And, of course, both are going to change signs, so whatever was positive is now negative, and whatever is negative is now positive, right? You're going to plot and finish this question, right? Okay. And as we continue along, I'm going to do even less and kind of put the onus on you. 180 degrees. Again, we're mapping our xy to opposite x, opposite y. On the number 9, I'm going to kind of jump down here, counterclockwise rotation, 90 degrees. That's this one right here. And what do we have? We have xy is going to get mapped to the opposite y, positive x. Again, just to give a couple of examples here, on B, if I start with -4, 7, they're going to switch spots. So B prime is going to go to 7, is going to go in the front, -4 is going to go to the back. But my focus is the fact that the y changes sign. So that's going to be -7, -4, right? Just the y changes sign. Let's try that one more time with D. Going to D prime, 2 and -5. First I switch their spots. And now again, just the y gets the opposite sign. So in the front, that's going to get the opposite. And I say y because that was the original y value. So -2, 5 should be, or -5 should be the coordinates. And then if I plot my point, my original B was -4, 7. So that's 1, 2, 3, 4, 7 is up here. That's B. And B prime is -7, -4. So 7 left and 1, 2, 3, 4 down. That's going to be my B prime. And that seems to be about right. 90 degrees clockwise. Counterclockwise drops me down 1 quadrant. Looks good. So you go ahead and finish the coordinates and finish your plotting. For number 8 up here, we have the 270 degrees counterclockwise. So that means that xy is going to get mapped to y -x, or opposite of x. So we got a flip-flop on the y's and the x values. So for h, 7, -6 goes to h prime. I'm going to put -6 here and 7. I know that they flip-flop, and according to this, the x value changes only, right? The y stays the same. So for number 8, h prime is -6, -7. Let's try one more with I. I originally started at 3, -8. They're going to switch positions, and what was once my x value is going to be the opposite. So 3, -8 will get mapped to -8, -3. Then plot and finish. And for number 10, you're going to do this one start to finish on your own. And what you want to do is complete 1 through 12, and then check that in with me for accuracy. All right? You're on your own. Good luck. Hopefully this was helpful.